I'm back. I realized I wanted to do an example of one more issue, which is the very profound and wonderful idea of putting a function inside another function. So let me do number 36. It was another one of the ones that we were looking at in class, but we didn't have time to finish. And this is f of x is x squared minus 1. And g of x is 1 minus 2x. And they ask us to do something weird. It's like, what the heck do they mean? F parenthesis g parenthesis minus 1 equals what? So what does this mean? Well, remember what this notation means. It's really, it's not multiplication. That's one thing I'm glad they point out. It's not the letter f multiplied by the letter x, which often we use parentheses for. It's the result of doing the process f on the input x. And here they actually define what f does. It says if you put any input in here, then you square that input and you subtract 1. Now what's really crucial is that it doesn't have to be x. That means that f of smiley face, for example, is whatever smiley face represents multiplied by itself and then subtract 1. Or f of squiggle equals squiggle squared minus 1. Believe it or not, that squiggle is actually a Greek letter. But it doesn't matter what that is. And more than just like, oh, it says, oh, maybe I get it. F of some single symbol is that single symbol minus 1. That's not it at all. It's f of anything in the world is that thing squared minus 1. And in particular, that thing could be the output of another process. So this says, take minus 1, stick it into G. That has this formula. Then that's going to give you a number. Then stick that number into F. In terms of the machine idea, a very good way to look at this is we're taking x, or taking minus 1, say, and we're sticking that into the G machine. It's going to spit out some output. We're going to put that in that box right in that little thing right there. And then we're going to stick that into the F machine, and then we're going to get the final output. It's a two-stage process. So it's called composing functions with each other. But we don't need to have the official name for it. We just have to use the basic definitions of functions. Now notice when I pointed to here, I pointed to the inside first. And that's crucial. Even though we usually read from left to right, functions are weird. It's an artifact of how people first invented the notation. And a lot of people say we should change it, but it's never going to get changed. Sorry. It's that you actually kind of go right to left on this one. Because the input, you want to start with the input. Like I like to analogize this to like an assembly line. Here's the raw materials. Here's the first stage in the assembly line. Here's the second stage. Now eventually out pops a car. You don't start with the car and then get the raw materials later. So here's the raw material. Here's the input to the first operation we're going to do. You actually start on the inside of the parentheses. So it's not so much about working left to right or right to left. It's working about inside out. And when you're evaluating a function that's made in this funky, complicated way, you start at the inside and you work your way out. So the other thing that's really important is when you're doing a multi-stage process in mathematics ever, you don't worry about the stage you're not working on. I'm going to rewrite the f of and not change it at all, and not try to worry about f. I'm not even going to use the definition of f. I'm working inside out, and I just need to know what this thing g of minus 1 is. Well, that's what happens if you plug minus 1 in for here. This notation means that g of minus 1 is whatever you get when you plug minus 1 in for here. You substitute x equals minus 1. That's 1 plus 2, so that's 3. So all I used was this definition for g. It's f of 3. Now, the g has gone away. And that's the idea of doing a multi-step procedure in mathematics. We focused on the g in order to get rid of it. And then we only have to work on the f. Now, we just have a 3 to plug into O, and we can see here's 3. That's that intermediate stage. Now we take 3, and we plug it into the definition of x, because f of anything is that thing squared minus 1. So f of 3 is that thing squared minus 1. 9 minus 1 is 8. So that's the process, the most basic process of combining functions in this way, of the output of g, that's not very legible, becomes the input of f. And the final output, so this is kind of like a temporary or sort of intermediate quantity. My handwriting is getting worse, isn't it? Because I'm rushing. Okay, it's a temporary intermediate quantity. It's important to the calculation, but it disappears at the end. We've put minus 1 in. We did two things to it, and an 8 pops out. So this turns out to be super important the more you do with functions, and especially if you ever go into the calculus arena, that's very important as well.